For what value of n is n minus 1 all factorial plus 1 equal to n squared? Before I start solving this, let me introduce the definition of a factorial. So when I say a factorial, what I mean is I'm multiplying an integer by all the integers below it up to 1. Let me explain. 3 factorial. This expression here means factorial. And when you see that in mathematics, what it means is that we are multiplying 3 by all the integers below 3. The next integer below 3 is what? 2. The next integer below 2 is what? 1. When we end at 1, that's it. We find the product of the result. And so 3 times 2 times 1 is 6. 4 factorial will mean we are multiplying all the integers below 4 up to 1. 4 by the next lower integer, 3 by the next lower integer, 2 by the next lower integer, 1. And that gives us 4 by 3, 12 by 2, 24 by 1, 24. 6 factorial will then be equal to what? 6 by 5 by 4 by 3 by 2 by 1. 6 by 5 is what? 30 by 4 is 120 by 3 is 360 by 2 is 720 by 1 is still 720. So that is actually the meaning of a factorial. So can you try your hands on these? 7 factorial equals what? And what is 10 factorial? Try your hands on that and give your answers in the comment section. Now let's solve the problem. So for what value of n is n minus 1 all factorial plus 1 equals n squared? So let me rewrite the question. N minus 1 all factorial plus 1 equals n squared. So this is what I do. I'm going to have to send the 1 to the other side. So that gives me n minus 1 all factorial equals n squared minus 1. Then from here, I'm going to so from here I can say n minus 1 all factorial equals n squared minus 1 squared. I just want to introduce the difference of two squares here because I'm seeing some similar expressions on both sides of the equation. So for this, I'm going to write n minus 1 factorial here equals, there's an identity. When you have n squared minus 1 squared, it's equal to n squared n plus 1 multiplied by n minus 1. We call this the difference of two squares. So in general, when I have a squared minus b squared, it is always equal to the sum of a multiplied by the difference, the sum of a and b multiplied by the difference between a and b. All right. So the reason I did 1 squared is that 1 is equal to 1 squared. So I just wanted to introduce that so that I can use that identity, that is the difference of two squares, to solve the problem. Or I can incorporate the difference of two squares in the solution. So that gives me n plus 1, then n minus 1 multiplied together. Let's proceed. Now from here, I can see n minus 1, but then this does not have a factorial. And so what I do is to clean up this a little bit. Let's come here. N minus 1 all factorial. According to the definition of a factorial, when I have this, it means that suppose that this is an integer. Of course, n is supposed to be an integer. Therefore, suppose that this whole thing is an integer. If I find the factorial of any integer, I'm multiplying that integer by the integer below it. How do we get the integer below any particular integer? We just subtract 1 from the integer. Look at this. 3 by the integer below it. The integer below 3 is 2. And how do we get the 2? We subtract 1 from the 3, and that's how we got the 2. And in the same way, we got the 1 by subtracting 1 from the preceding integer. So in that case, if I want to find the factorial of this, I get n minus 1. The integer comes, then the integer below it, by subtracting 1 from that will be n minus 1 or minus 1, and that's equal to n minus 2. I can multiply by n minus 3, n minus 4, up to whatever it will give us in the end. But then I don't need all that. I'm only going to write n minus 1 times n minus 2, but then I'll put a factorial because there's a series of multiplications. I'm not done with the multiplication. Since n is not known, this will be an infinitive product. And so that's what I'm going to do. I'm writing n minus 1 multiplied by n minus 2 factorial, and that's equal to n plus 1 times n minus 1. Now here, n minus 1 is here, n minus 1 is here, so they've cancelled out. That is, I'm just dividing this expression by n minus 1, and the right hand side, which is n plus 1, all times n minus 1. Divide that 2 by n minus 1, so that this can cancel out this, and this can cancel out this. And so from here, I'm getting n minus 2 all factorial to be equal to n plus 1. Now, I'm going to use a technique. Now look, I have a factorial here, I don't have a factorial here. So the best thing is to let's say a variable p represent n minus 2. That is, n minus 2 equals p. In that case, my n will then be equal to p plus 2. If I want n, I just send 2 to the left, and that gives me positive 2. And so I can rewrite that as n equals p plus 2. Now let me name this equation, let's say A. So equation A becomes n minus 2. Whenever I see n minus 2, it's always p. So I put a p factorial, right? And that's equal to n here is always p plus 2. So I replace that with p plus 2, then plus 1. Everything plus 1. Don't forget, n itself is p plus 2. And so plus 1 will be added. Then here I get p factorial equals p plus 3 when I simplify the right hand side. So that gives me p plus 3. Now, this is what I'm going to do. Let's see. I'm going to expand p factorial, and that gives me p times p minus 1 all factorial. You get it? From the previous analysis that we made, equals p plus 3. At this point, p times p minus 1 all factorial minus p, I'm sending p to the left, will then be equal to 3. Then at this point, I'll factorize p out. When I factorize p out, I get p minus 1 all factorial minus 1 here equals 3. That is, p is a common factor, so when I factor it out, this side becomes p minus 1 factorial left, and over here I get 1 inside. Now at this point, I am going to make some analysis. Look, I have p times p minus 1 factorial minus 1 here, and that's equal to 3. P times p minus 1 all factorial all minus 1 equals 3. Now, what this means is that, don't forget that this is a product. This is a product. What I'm trying to say, therefore, is that, the expression is P outside, P minus 1 all factorial, then minus 1. Yes, that's how it's supposed to be. Yeah, sorry for that. Now, from here, what it means is that the product, now, this whole thing is one expression because they are together in a bracket, and this is also another expression, so they are multiplying. What it means is that the product of two numbers gives us 3. The only possibility, in fact, the product of two integers is actually 3. Let me put it that way. The only possibility, the only integers whose product is 3 are 3 and 1. You get the point. And so what it means is that P times P minus 1 all factorial minus 1 is equal to 3 times 1. The only possibility is that P times that will be equal to 3 times 1. The only possibility for the product of any two integers to be equal to 3 is actually 3 times 1. Good. So P will then, so what it means is that we are just comparing. If this times this is equal to this times this, what it means is that P can be said to be 3. P equals 3. But then that is on condition that whatever this P here is will also be equal to 3. Let's see. If P is 3, then when we solve this to be equal to 1, we should get P to be 3. And that is the only way we can say P is equal to 3. Let's see. P minus 1 all factorial minus 1 is equal to 1. So in that case, I'm going to have P minus 1 all factorial to be equal to 2. I send the 1 there, and that becomes 2. Then from here, I get P minus 1 all factorial to be equal to, now I can express 2 as a factorial, in which case it's going to be 2 factorial, because 2 multiplied by the lower integer, that is 1, is still 2, and so 2 factorial is equal to 2. So I can write 2 as 2 factorial. Then since both have a factorial, the inside here, P minus 1, will then be equal to 2. That implies that P is indeed equal to 3. That is true. So since P is equal to 3 here, and then this expression when equated to 1 gives us 3, it means that P is indeed 3. Therefore, P is indeed equal to 3. Good. So that is it. Now let's come to the final part. The question did not have any P, and we are supposed to solve for n. Therefore, let's go back to introduce our substitution. We said we should let P is equal to n plus 1. We should let P be equal to n plus 1. P be equal to n minus 2, but P is equal to n minus 2. So what we do is to bring back our P, which is 3, substitute it into this expression. That gives us n minus 2. So when we bring 2 to the other side, that gives us n. Therefore, n is equal to 5. And that's the solution. We can cross-check and see if we are right. The question was n minus 1 all factorial plus 1 is equal to n squared. So how? Let's see if 5 satisfies this expression. Let's do the left-hand side. 5 minus 4 all factorial plus 1 is equal to 5 squared. Let's see if that is true. 5 minus 1 here, 5 minus 1 is 4. factorial plus 1 equals 5 squared. Let's see, 4 factorial is 24. 4 times 3 times 2 times 1 is 24. Plus 1 is equal to 5 squared is 25. And that is true. 25 here and 25 here. That means it satisfies. Therefore, n is indeed equal to 5. That's it. Thank you.